So think about a live sports broadcast. You've got the 4K camera down in the field. The announcers are way up in the booth. But, their voices and that crystal clear video arrive on your screen at the exact same millisecond.
Right, and it feels completely seamless to the viewer, but it's actually just highly specialized digital plumbing.
Exactly. And welcome to today's deep dive, where we're looking at one specific piece of that plumbing, the AJA 12G-SDI Embedder. We're using a product page and some customer reviews from a retailer called HDTV Supply to figure out how this tiny box manages like a flawless 4K stream without breaking a sweat.
Yeah, and the name itself is actually a great place to start. It's an embedder and a disembedder.
Which sounds super technical, but I mean, think of it like an incredibly fast zipper. It either zips audio and video together into a single cable, that's the embedding part, or it, unzips them so you can route them to totally different places.
And that zipper needs to be really fast because of the 12G-SDI part of the name.
Correct.
That essentially translates to the massive bandwidth required to push uncompressed 4K video.
Which is a heavy load of data.
Oh, it's an insane amount of data.
Yeah.
And 4K signals degrade pretty quickly over standard copper wire because of the electrical resistance. So that's why this specific unit ships with an LC Fiber Rx SFP.
Okay, wait, let's translate that for a second. It uses a fiber optic receiver, right?
Exactly.
Yeah. So instead of fighting that electrical resistance on a copper wire, it just converts the data into pulses of light.
Right, which lets it travel massive distances, like all the way across a stadium, without losing a single pixel.
Wow. And the physical contrast here is just crazy to me. You've got this massive multi-lane highway of 4K video data and audio, and it's all being squeezed into a metal box that's, only 5.8 inches wide?
It's barely bigger than a smartphone.
Yeah. But why unzip the data at all? Like, if the camera already captured the audio and video together on the field, why go to the trouble of separating them on the fly?
Well, because the embedding is actually user selectable on a per-channel pair basis.
Okay, meaning what exactly?
Yeah. So imagine you're broadcasting the Olympics, right? You have the raw 4K video and the stadium crowd noise coming in together.
Right, the natural ambient sound.
Yeah. This device allows a broadcast engineer to strip out just one pair of audio channels and replace it with, say, a local language commentator.
Oh, I see.
But it leaves that totally immersive stadium crowd noise completely intact.
That makes total sense. And to physically plug in those different microphones or soundboards, it uses an XLR breakout cable. Those thick, heavy-duty 3-pin cables you always see plugged into professional mics.
Exactly, the heavy industry standard stuff.
But I have a massive point of confusion here, though. We're talking about a device handling bleeding-edge 4K data with, pulses of light. But to configure it, you literally flip tiny mechanical analog DIP switches on the side of the box.
I know.
Doesn't that feel like putting a cassette deck inside a spaceship?
It really does seem kind of archaic.
Yeah.
But you have to remember that broadcast engineers need absolute foolproof reliability. A mechanical switch can't crash.
Right, it can't get hacked during a live broadcast.
Exactly. It just stays exactly where you flicked it. But you're highlighting a real friction point here.
Mm-hmm.
Bridging the gap between a perfect theoretical spec and the messy reality of actually building an AV system.
Which brings us to the retail reality, where professionals actually buy this gear. You look at customer reviews for retailers like HDTV Supply, and you immediately see that friction.
Yeah, like one buyer, Mike P., he had a LAN camera that kept constantly auto-deleting itself from his setup whenever a program was closed.
Or Prasad R, right. He ordered an item, waited 10 days, and then found out it wasn't even being manufactured anymore.
Right, because an AJA embedder is so critical, just acquiring one and integrating it becomes this high-stakes puzzle.
Yeah, it really makes you wonder, does it even matter how pristine a device's technical specs are if the supply chain fails or the broader system integration is just super buggy?
Yeah, the weakest link dictates the entire broadcast.
Ultimately, this AJA embedder acts as a tiny but mighty bridge in the whole complex world of high-end audio and video routing. It basically zips and unzips the digital world so you can consume media flawlessly.
Right, it's that invisible physical infrastructure that really makes modern screens come alive.
Which leaves you wondering about the future, right? As broadcasting moves increasingly into the cloud and, AI starts dynamically mixing audio and video virtually in real time.
But definitely.
What happens to our modern communication when just one physical 5.8-inch box in that massive invisible chain decides to stop working?